You're watching Infinite Universe NTH, and I'm Orion, your guide as we explore the wonders of science, space, and the mysteries that connect Earth to the cosmos. If you enjoy journeys that spark curiosity and reveal the beauty of the universe, please consider subscribing. It truly helps me stay inspired to bring you more stories like this. Now, let's begin our story. 1. The Barringer Crater, United States. Long before telescopes and satellites allowed humanity to study the heavens, a visitor from space left a lasting mark on the Earth itself. Around 50,000 years ago, an iron-rich meteor entered our atmosphere and touched down in what is now northern Arizona, creating one of the most remarkable geological features on the planet. The result was a circular basin nearly 1.2 kilometers, 0.75 miles, wide and over 170 meters, 560 feet deep, a formation so striking that it still appears almost otherworldly today. Scientists now call it Meteor Crater, or more formally, the Barringer Crater, named after the man who first revealed its cosmic origin. For centuries, people were unsure how such a vast depression had formed. Some believed it was the remnant of a volcanic event, while others thought it might be the result of underground activity. In the early 1900s, however, Daniel Barringer, a mining engineer with a passion for geology, proposed a bold idea. The crater had been created by the impact of a meteorite from space. His claim was controversial at the time. The concept that a celestial object could shape Earth's surface was almost unheard of. Yet Barringer devoted decades to studying the site, carefully collecting samples and data that would one day prove him right. Modern research has since confirmed his insight. Scientists discovered microscopic metallic particles, melted rock, and unique minerals around the crater, all evidence of a high-energy impact that occurred long ago. These findings helped establish a new branch of geology devoted to studying how celestial bodies interact with planets. The Barringer Crater became the first verified impact site on Earth and remains one of the most perfectly preserved examples anywhere in the world. Today, standing at the rim of the Barringer Crater offers a humbling perspective. The quiet desert landscape contrasts with the powerful natural event that shaped it tens of thousands of years ago. It serves as both a scientific landmark and a reminder that our planet has always been part of a much larger cosmic story, one written across the skies above and the rocks beneath our feet. 2. The Tunguska event, Russia. In the early morning of June 30th, 1908, a quiet summer sky over central Siberia was suddenly filled with light. Witnesses across hundreds of kilometers saw a glowing streak move across the horizon, brighter than the rising sun, followed moments later by a deep wave of sound that echoed through the forested landscape. The event, which became known as the Tunguska event, remains one of the most fascinating natural mysteries in modern science. For years, no one knew exactly what had happened. The region was remote and sparsely populated, and it wasn't until almost 2 decades later that an expedition reached the site. What the scientists found was astonishing. Trees over an area of more than 2,000 square kilometers had been flattened, all pointing away from a single central point. Yet there was no crater, no large meteorite fragment, only scorched soil and scattered traces of melted minerals. After decades of research, scientists determined that the Tunguska event was caused by a small asteroid or icy comet fragment, roughly 50-60 meters wide, that entered Earth's atmosphere at tremendous speed. Before reaching the ground, the object heated and fragmented high above the surface, releasing a burst of energy that produced the visible flash and shockwave observed from afar. Because the event occurred in an isolated area, there were no lasting impacts on communities or wildlife, but it provided scientists with extraordinary clues about how near-Earth objects behave when they interact with our atmosphere. the Tunguska event became a cornerstone for modern planetary science. It was the first time researchers realized that even relatively small space objects could release vast amounts of energy high above the ground without leaving a crater behind. Decades later, advanced studies of the area's soil and tree rings revealed traces of rare chemical elements, confirming the extraterrestrial origin of the event. Today, Tunguska stands as both a mystery and a milestone, a reminder of how dynamic and interconnected Earth's relationship with space truly is. What began as an unexplained light in the Siberian dawn has since inspired generations of scientists to study the skies, leading to many of the observation systems that watch over our planet today. 3. The Buzzard-Coulee Meteorite, Canada. It was a cold November evening in 2008 across the open plains of Saskatchewan, Canada, when the quiet of the prairie transformed into a spectacle of light. The event would later be known as the Buzzard-Coulee Meteorite Fall, named after the valley where its fragments were found. At around 5:30 p.m. local time, a sudden burst of white brilliance streaked across the horizon. A fireball bright enough to cast moving shadows and turn the frozen farmland into a glowing landscape of daylight. Police dash cams and highway security cameras captured the entire descent, a blazing meteor racing from northwest to southeast before fragmenting into hundreds of luminous pieces that faded beyond the distant hills. Subsequent analysis confirmed the object was a Type H4 ordinary chondrite, a stony meteorite rich in iron and silicate minerals. Measuring about 1 meter in diameter and weighing nearly 10 metric tons, it entered Earth's atmosphere at roughly 31,000 miles per hour, 50,000 km/h. The tremendous friction caused its surface to reach thousands of degrees, forming a bright trail of ionized gas before it disintegrated 20 miles, 32 kilometers, above the ground. The resulting energy burst, equivalent to several tons of TNT, produced a flash visible across 3 Canadian provinces. Within hours, researchers from the University of Calgary and the Canadian Fireball Network began gathering more than 400 eyewitness reports to precisely calculate its trajectory. In the following days, scientists and local residents searched the snowy fields near Buzzard-Coulee. More than 1,000 fragments were eventually recovered, some weighing over 13 kilograms, 29 pounds. Inside, the meteorite revealed well-preserved chondrules, microscopic mineral spheres older than Earth itself. Laboratory studies traced its origin to the asteroid belt between Mars and Jupiter, making it one of the most scientifically valuable meteorite falls ever recorded in North America. What made the Buzzard-Coulee event truly exceptional wasn't its size, but its completeness, the perfect combination of visual evidence, recovered material, and precise orbital data. For the first time, scientists documented every stage of a meteor's journey, from its fiery entry through the atmosphere to its final resting place on Earth. Today, the Buzzard-Coulee meteorite stands as one of the most thoroughly studied falls in modern history, a cornerstone case that continues to refine how researchers understand meteor trajectories and the dynamic pathways of small bodies within our solar system. 4. The Chelyabinsk meteor, Russia. Morning in southern Russia was just beginning when, at 9:20 a.m. on February 15, 2013, the sky above the industrial city of Chelyabinsk suddenly ignited. A brilliant white flash swept across the horizon, brighter than the sun itself, followed seconds later by a deep atmospheric rumble that rolled through the streets. Windows rattled, car alarms sounded, and countless dash cams recorded what would soon be recognized around the world as the Chelyabinsk meteor. Subsequent analysis revealed that the object was a stony asteroid, approximately 17 meters wide and weighing around 12,000 metric tons, entering Earth's atmosphere at an astonishing speed of 19 kilometers per second, 500 nanometer. As it descended, the immense pressure and heat caused it to glow intensely and fragment high above the ground, around 30 kilometers, 19 miles, in altitude. The resulting energy release, estimated at 500 kilotons of TNT, was nearly 30 times greater than any previously observed atmospheric event of its kind. The atmospheric pressure wave generated by the disintegration traveled around the planet twice, strong enough to cause windows to shatter across 6 Russian cities. More than 1,500 people received treatment for minor cuts from broken glass, while the flash was visible for hundreds of kilometers in every direction. Orbital sensors also detected the burst immediately, confirming its magnitude and trajectory. Despite the immense release of energy, no crater was found. The meteor had completely disintegrated in the upper atmosphere, scattering thousands of small fragments over Lake Chelyabinsk, where divers later recovered several kilograms of material. Laboratory analysis confirmed that the Chelyabinsk meteorite belonged to the LL5 ordinary chondrite class, containing minerals formed over 4.5 billion years ago, remnants from the earliest era of our solar system. The Chelyabinsk event became a turning point for planetary defense research. For the first time, scientists had access to a complete and coordinated data set: video, infrasound, seismic, and orbital measurements, all from a single meteor entry. Using this wealth of data, space agencies refined their models for fragmentation dynamics and atmospheric energy distribution, significantly improving early detection and response systems for near-Earth objects. Today, the Chelyabinsk meteor remains a cornerstone in modern astronomy, a vivid demonstration that even a relatively small visitor from space can reshape our understanding of impact physics, atmospheric behavior, and the ever-active nature of the skies above us. 5. The Bahia Fireball, Brazil. It started as whispers in the night, scattered calls, brief posts online, people across northeastern Brazil describing a flash so bright it turned the sky white. Minutes later, surveillance footage from the city of Feira de Santana confirmed what witnesses had seen: a brilliant sphere descending from the upper atmosphere, glowing brighter than the full moon before silently fading away. The event would later be catalogued as the Bahia Fireball of 2014, one of the most precisely recorded meteor events in South America. Across several towns in Bahia state, the night briefly became day. The object's path stretched for nearly 300 kilometers, cutting a luminous line across the sky that lingered for seconds before vanishing without sound. Analysis of multiple recordings by the Brazilian Meteor Observation Network, BRAEMON, determined the object's velocity to be about 60,000 kilometers per hour, 37,000 km/h. Based on its brightness, researchers classified it as a bolide, a type of meteor that reaches extreme luminosity before breaking apart. The energy released was equivalent to several tons of TNT, powerful, but far above the surface, where the atmosphere safely absorbed the shock. No fragments were recovered, but BRAEMON scientists reconstructed the object's trajectory with high accuracy. The calculated orbit pointed toward the Apollo group of near-Earth asteroids, a family known for intersecting Earth's path as they circle the Sun. Spectral analysis suggested a stony composition with a high magnesium and silicate content, consistent with typical Apollo-type meteoroids. This data made Bahia one of the first confirmed bolide cases from that orbital group observed over South America. For researchers, the Bahia Fireball demonstrated how local observation networks could contribute global-scale science. For residents, it was unforgettable. A few seconds when the stars gave way to a single, brilliant visitor from space. The sky returned to darkness almost immediately, but for those who saw it, the image of that glowing descent stayed long after the light was gone. 6. The Shangri-La Bolide, China. The night sky above Yunnan was clear and tranquil, glowing under the full light of the mid-autumn festival moon. Families gathered in courtyards and open fields to admire its calm beauty when an unexpected brilliance began to rise near the horizon. What first appeared as a single streak of light quickly intensified, expanding into a blue-green radiance that rivaled the moon itself. Within seconds, the entire valley of Shangri-La, a city surrounded by snow-capped peaks, was bathed in color as bright as daylight. Footage from multiple provinces, Yunnan, Sichuan, and Tibet, captured the same breathtaking moment. The meteor, later classified as the Shangri-La bolide, entered Earth's atmosphere at a shallow angle and tremendous speed, estimated near 14 kilometers per second, 31,000 km/h. As it skimmed the upper atmosphere, it released energy equivalent to roughly 540 tons of TNT, creating one of the most brilliant atmospheric bursts ever recorded over China. The brilliant flare illuminated entire mountain ranges, followed moments later by a low, rolling echo that reverberated through the thin mountain air. Spectral data from Chinese observatories revealed high concentrations of magnesium, iron, and nickel, explaining the meteor's striking blue-green glow. Its shallow entry path allowed it to glide through the atmosphere for several hundred kilometers before completely disintegrating at an altitude of around 37 kilometers, 23 miles. Despite extensive searches by research teams, no meteorite fragments were found, confirming that the object had vaporized entirely before reaching lower altitudes. The Chinese Academy of Sciences later identified the Shangri-La bolide as one of Asia's best documented meteor events of 2017. The data it provided offered valuable insights into how a meteor's composition and entry angle affect its color, brightness, and visual behavior, information now used to improve global optical observation systems. For those celebrating beneath it, the sight felt almost poetic, as if the universe had joined their festival with its own lantern, silently crossing the heavens. In a fleeting instant, the mythical charm of Shangri-La met the cosmic reality of deep space, and the night that began with the moon ended illuminated by light that had traveled for millions of years to be seen. 7. The Yushu Sky Flash, China. The people of Yushu are used to seeing stars brighter than in almost any other part of China. At an altitude of over 3,600 meters, the sky above the Tibetan Plateau feels impossibly close. But in the early morning of December 23, 2020, that familiar darkness was shattered by an event so luminous that it temporarily erased the stars themselves. At 7:23 a.m. local time, a fireball later designated the Yushu meteor, Keneos 2020-12.3, entered Earth's atmosphere, turning the mountain valleys into a stage of unearthly light. Dashcams and security cameras across Qinghai and Gansu provinces captured the moment, a glowing white sphere traveling silently before exploding into a flash bright enough to trigger streetlights and set off automatic sensors. For roughly 5 seconds, night became day. Experts from the China Earthquake Network Center, CENC, detected a faint atmospheric tremor coinciding with the visual burst, not from an impact, but from the shock wave created high above the plateau. Subsequent analysis confirmed that the Yushu meteor was traveling at 32 kilometers per second, 72,000 km/h, and likely measured between 5 and 10 meters in diameter. It disintegrated at an altitude of around 35 kilometers, 22 miles, releasing energy equivalent to 9.5 kilotons of TNT. Despite the magnitude of the event, the explosion occurred so high that no damage was recorded on the ground. Satellites later confirmed the flash was visible from orbit, marking one of the brightest atmospheric entries of 2020. Chinese researchers compared the Yushu data with global detection networks and classified the object as a carbonaceous chondrite, a rare type of meteorite rich in organic compounds and volatile minerals. Its soft composition likely contributed to its complete vaporization before reaching lower layers of the atmosphere. The Yushu meteor became a landmark event for high-altitude observation in Asia, confirming that large airbursts can occur safely far above Earth's surface. Brilliant, but harmless. For the residents who witnessed it, the moment was unforgettable. In a place where the sky already feels near, that morning it seemed closer than ever, alive, immense, and glowing with the power of a visitor from deep space. 8. The Idaho Fireball, United States. Just after midnight on July 4, 2022, residents across Idaho and neighboring states witnessed something extraordinary streaking through the summer sky. A brilliant blue-white fireball, later cataloged as the Idaho Bolide, tore across the atmosphere, lighting up the western horizon for nearly 10 seconds. From backyard observers to security cameras and dash cams, the scene repeated everywhere, a glowing orb trailing sparks, breaking into several bright fragments before fading behind a layer of thin clouds. The American Meteor Society, AMS, received more than 80 reports from 6 U.S. states: Idaho, Montana, Oregon, Washington, Utah, and Wyoming. Based on the data and videos submitted, experts estimated the meteor entered Earth's atmosphere at a speed of about 45,000 miles per hour, 20 kilometers per second, and disintegrated at an altitude of around 30 miles, 48 kilometers. The intensity of its brightness placed it among the largest fireball events recorded in North America that year. Spectral analysis from amateur astronomers revealed a composition rich in magnesium and silicate, producing the blue-green hue that mesmerized viewers across the region. NASA's Meteor Watch program later confirmed that the object was most likely a fragment from an asteroid belonging to the Apollo group, a family of near-Earth objects with orbits that occasionally intersect our planet's path. No fragments were recovered, indicating the meteor fully vaporized before reaching lower altitudes. What made the Idaho Bolide remarkable was not its size, but its reach. For a few seconds, millions of people shared the same sky, each video clip, each gasp, combining into one of the most documented celestial events of 2022. For scientists, it offered high-quality data to refine entry models. For everyone else, it was a quiet but unforgettable message written in light, reminding us how small yet connected we remain beneath the same cosmic trail. 9. The Atlantic Flash, Iberian Peninsula Bolide, Spain and Portugal. It was just past midnight on May 18, 2024, when the night sky over the Iberian Peninsula suddenly ignited. From Lisbon to Madrid, countless people stopped in their tracks as a brilliant blue-green flash raced across the heavens. For nearly 5 seconds, it blazed brighter than the moon, illuminating rooftops, highways, and even the waves along the Atlantic coast. Later named the Iberian Peninsula Bolide, it became one of Europe's most spectacular meteor events in recent decades. European observatories, including the European Space Agency, ESA, and Spain's Instituto de Astrofísica de Andalucía, analyzed dozens of recordings to reconstruct its flight path. The meteor had entered Earth's atmosphere over the Atlantic Ocean at a velocity of 40.4 kilometers per second, about 90,000 km, and disintegrated high above the surface. Preliminary calculations placed its mass at roughly 1 metric ton and its energy release at between 2 and 3 kilotons of TNT. The fireball's brightness reached magnitude 18, rivaling the intensity of the sun's reflection off ocean waves, a truly rare level of luminosity for a natural meteor event. Footage from Portugal's meteor monitoring stations revealed a vivid electric blue hue, a sign of magnesium-rich material burning during fragmentation. The object was determined to have originated from the comet 2P Encke debris stream, the same source responsible for the annual Taurid meteor shower. Unlike smaller meteors, this bolide burned long enough to be tracked simultaneously by ground cameras and orbiting satellites, allowing scientists to capture precise data on its speed, altitude, and decay. No fragments were found, as it fully disintegrated over the Atlantic. But the event left behind something else: hundreds of videos and eyewitness accounts that turned the Iberian sky into a moment of shared astonishment. For researchers, the Atlantic flash became a benchmark case for how coordinated global observation networks can transform a fleeting celestial event into a lasting scientific record. Dazzling, the Georgia fireball, United States. Just before midnight on June 26, 2025, night security cameras across the southeastern United States caught sight of a sudden burst of light cutting through the clouds. The object, later designated the Georgia fireball, streaked over Alabama, Georgia, and South Carolina before fragmenting in a flash that turned the sky white for several seconds. Witnesses described the light as so bright it momentarily drowned out the stars. Within hours, NASA's Meteor Watch team confirmed the event through multiple ground and space-based detections. Analysis of its trajectory showed that the fireball entered Earth's atmosphere at a speed of 43 kilometers per second, about 96,000 mph, disintegrating at an altitude of roughly 43 kilometers, 27 miles. Scientists estimated its energy release equivalent to 20 tons of TNT, enough to create a visible shockwave captured by several atmospheric monitoring systems. The object was likely about 1 meter in diameter and weighed close to a ton before breaking apart completely. Dozens of cameras from home security networks, dash cams, and even storm-tracking satellites recorded the phenomenon from different angles, allowing researchers to pinpoint its entry path across 3 states with remarkable precision. Its orbital reconstruction traced it back to the Aten group of near-Earth asteroids, a family known for their tight, fast orbits inside Earth's own path around the Sun. While no fragments were reported to reach the ground, the Georgia fireball quickly became one of the most thoroughly analyzed meteor events in recent years. The volume of data collected in a matter of hours reflected how far global observation systems have advanced since Chelyabinsk. What once required chance and luck now relies on networks of sensors, satellites, and citizens, all watching the same sky, waiting for the next brilliant reminder of how dynamic our planet's atmosphere truly is. From the ancient plains of Arizona to the quiet skies of modern Georgia, these 10 moments trace humanity's long conversation with the universe. Each event, whether carved into rock, captured on camera, or remembered in story, has added another layer to our understanding of the world beyond our atmosphere. Together, they form a timeline of discovery. The Barringer crater showed us that the Earth bears the marks of its encounters with space. Tunguska reminded us of the unseen forces that move through the skies, and the modern fireballs, from Canada to China to the Iberian Peninsula, revealed how science and technology can turn fleeting light into lasting knowledge. Across continents and generations, the same pattern repeats: curiosity, observation, and awe. What was once a mystery seen only by chance has become a field of study uniting scientists, cameras, satellites, and ordinary observers under the same shared sky. Each light that crosses the night reminds us that we are part of a living system, a planet shaped not just by what happens on its surface, but by the vast space surrounding it. None of these events brought harm, yet all of them changed how we look upward. They taught us to listen to the sky, to study its brief signals, and to find meaning in the moments when Earth and the cosmos meet. And as technology advances, one truth remains constant: the universe is always speaking, sometimes quietly, sometimes in flashes of brilliance, and we are still learning to understand its language.